What's up, everybody? So we are getting into 5.4 today, graphing using intercepts. Okay, so first thing I guess to understand is this is what we're learning today, a new way of graphing lines. Okay, in the previous couple of lessons, we've been graphing using tables. Okay, today we're going to look at a new way to graph, and then actually the next lesson we'll learn another way to graph. Okay, so yeah, today is graphing using the intercepts, and basically what the intercepts of a graph are is where they cross the x-axis and the y-axis. It's where they intercept those two axes. All right, so real quick, go ahead and get the title here. Go ahead and copy this graph. By the way, I have graph paper. If you'd like to print it out, you can do that and do your notes on it. Or if you'd like to do it on a separate sheet of paper, that works as well. Okay, but go ahead and get this first line on your first graph, and then I'll show you what's going on. Okay, so basically, you guys can see that the points on this graph are on the intercepts, the axis. Okay, one's on the x-axis and one's on the y-axis. All right, and yeah, the intercepts, the x-intercept here would be at 3, 0, and the y-intercept would be at 0, 6. Okay, so the first problem we're going to see is one that gives us a graph and asks us to find the intercepts. And it's literally just the 2 points where it crosses the 2 axes. Okay, so we're going to do that on this example right here. So on your next graph, go ahead and get these directions above it, and go ahead and get this first graph here, and then we'll do together. Okay, so identify the x and the y intercepts. First one, let's go ahead and find the x-intercept. Okay, that's where it intercepts the x-axis, and we can see it's right there. So our x-intercepts, usually I do this for shorthand. So x-intercept, okay, that point is at 5 on the x, 0 on the y. So 5, 0 is our x-intercept. Okay, our y-intercept, we can see down here, crosses at -6 on the y-axis. So same idea, the y-intercept of this graph is at, careful, be tempting to say, oh, -6, 0. No, 0 on the x down to -6 on the y. So 0, -6. Okay, so there are the two intercepts. So when you're looking for them, when you are already given a graph, it's very, very simple. Okay, on both, that's not what this is about today, but let's see here real quick. Okay, so let's actually get into a problem that's asking us for the x and the y intercept again, but is not giving us a graph. Okay, go ahead and copy this and I'll show you how we do it. Okay, well, this is actually a good illustration of what we're going to do. When we're looking for the x-intercept, if you guys notice, we had 0 for y. Okay, and when we looked for the y-intercept, we had 0 for x. Okay, and that's exactly what we're going to do. When they give you an equation and they ask you for the x-intercept, you're going to plug in 0 for y. Okay, when they ask you for the y-intercept, you're going to plug in 0 for x. Okay, so that's the idea. So on this problem here, let's start by finding our x-intercept. Okay, to do that, again, I'm plugging in 0 for y. All right, and if you want to maybe give yourself a little note, we can say for x, we could say plug in 0 for y. Okay, if you wanted to kind of just remind yourself. And then for this one, same idea. We can say, okay, to find the y-intercept, we'll plug in 0 for x. Okay, so that's not a bad reminder to put in your notes. All right, so yeah, let's go ahead and find that x-intercept. So I'm going to rewrite this equation. And let's show ourselves in our notes that we're finding our x-intercept. So this is us finding our x-intercept. I'm going to rewrite our equation, 2x plus 7 times y. But again, we're going to plug in 0 for y to find our x-intercept. Okay, and now we're just solving. So it looks like we're going to get a 2x. This just turns into a 0. It disappears, basically. So we get 2x equals 28. And divide both sides by 2 here. It looks like x is going to equal 14. Okay, so our x-intercept is at 14, but let's actually write out the coordinates of it. So that means it would actually be at 14 on the x, 0 on the y. Okay, this is actually the coordinates of our x-intercept. I kind of like that answer better than just x equals 14. Okay, let's do the same thing for our y-intercept. All right, so I'm going to rewrite my equation, but this time I'm going to plug in 0 for x to find my y-intercept. So 2 times 0 plus 7y equals 28. Okay, again, that 2 times 0 turns into 0, disappears, and we're left with just 7y on the left, 28 on the y. Divide both sides by 7. These are all working out nice and clean, right? And we're getting y equals 4. Okay, so the coordinates to our y-intercept, be careful, is 0 on the x, 4 on the y. All right, so yeah, it's not too shabby. We're just plugging in zeros and solving. So I'm gonna have you guys try one just like this, same directions. You don't need them again. Go ahead and find the x and y-intercept for this equation. All right, so starting with the x-intercept here. All right, that means I'm plugging in 0 for y, so I'm going to rewrite my equation, plus 5, and I'm going to plug in 0 for y there, equals negative 15. Okay, this disappears, and I'm left with just 3x, negative 3x on the left, negative 15 on the right. Divide both sides by a negative 3, and it looks like x is going to equal 5. Okay, but again, don't stop there. Actually give me the coordinates. That means it's at 5 on the x, 0 on our y. So there is my x-intercept. Let's go ahead and do the same thing for y. Am I mixing up my colors? Yeah, sorry, I did blue over here. Now I'm doing green. Here, let's see if I can fix this. It's gonna bother me. I'm gonna change this real quick. Okay, x-intercept. There we go. We'll keep this consistent. So y-intercept. Okay, let's go ahead and do it. Same idea, but I'm gonna now plug in 0 for x. So negative 3 times 0 plus 5y equals negative 15. This turns into a 0, disappears, so we're left with 5y on the left, negative 15 on the right. Divide both sides by 5. Looks like y is going to equal a negative 3. Okay, so the coordinates to our y-intercept is at 0 on the x, negative 3 on the y. All right, so now that we know how to do this, we can actually graph these equations on an actual graph really easily. Also, something I should have said, it's probably too late already, but if you were using the graph paper, you'd probably just want to do these last couple problems on the back side of it. Maybe I'll put a note in. Okay, so the next one here, we're actually going to do just that. We're going to graph using intercepts here. So above your next graph, go ahead and get this equation, and we'll do just that. Okay, so let's go ahead and start by getting our x-intercept, just like the last problem. Nothing really different here. We're just going to then graph those points. Okay, so that means I'm plugging in 0 for y, right? So I got a negative 4x plus 2 times 0 equals 4. Okay, this disappears. I have a negative 4x equals 4. Divide both sides by negative 4. Looks like x equals negative 1. Okay, so, just by the way, this right here would be enough. We'd say, okay, that means on the x-axis at negative 1, there's my x-intercept. Okay, but again, I want you to go one more step and actually give me that coordinate. That would be negative 1 on the x, 0 on the y. Okay, let's go ahead and do the same thing for our y-intercepts. All right, I'm going to put a little line dividing these. Okay, so finding y-intercept, that means I'm plugging in 0 for x. So negative 4 times 0 plus 2y equals 4. All right, negative 4 times 0, 0 disappears. So we got 2y equals 4. Divide both sides by 2. Looks like y equals 2. And again, that would be enough for me to say, okay, there's my y-intercept at positive 2. But let's do the coordinates, 0 on the x, 2 on the y. Okay, and look at, we have 2 points, and to graph a line, we really only need 2 points. We've been doing 5 points when we make tables, but it's not necessary when we're dealing with intercepts. We have 2 points, we can connect them, and we can get our line. Remember, put your line all the way across your graph, because technically it goes on forever. Okay, if we wanted to get a more accurate graph, we could plot more points. If we wanted to, we could plug in, say, 3 for x, and we would get a y point somewhere up here. If we wanted to get more points on this, we could, but I'm not requiring it when you do your intercepts. I just need the intercepts. Okay, so with that, I'm gonna have you guys try one on your own. Go ahead and find the x and y intercepts and plot them and get your graph. All right, so starting with my x-intercepts, all right, plugging in 0 for y, I have 3x plus 2 times 0 equals 6. That disappears. 3x equals 6. Divide by 3, x equals 2. I'm going through this really quick. If you need a pause, that's fine. But I'm assuming that you tried this on your own and that you're doing just fine. Okay, so there's my coordinate, 2 on the x, 0 on the y. So over here, there is my x-intercept. Okay, next one, y-intercept. Okay, plugging in 0 for x, 3 times 0 plus 2y equals 6. Okay, that disappears. 2y equals 6. Divide both sides by 2. Looks like y equals 3. Okay, so our y-intercept is going to end up right there. Let's get the coordinates though. 0 on the x, 3 on the y. There's my y-intercept. Okay, and connect the dots, and we have our graph. Okay, so that's graphing using intercepts. It's actually pretty simple idea. Here are the, I guess, the downside to graphing with intercepts. Say you had a graph here, and say its line looked like, just for example, say after you graphed it, you got a line like this. Okay, that green line. Well, we could see that the y-intercept would be, like 6.2 or whatever it happened to be, but we wouldn't be able to see where our x-intercept is. Okay, so when it came to graphing this line, it would be hard to do because the points that we're putting on are falling off our graph. Okay, so that's why intercepts sometimes are not great. Also, if we were to get some weird intercepts, like say this intercept, like I said, was 6.2, be some strange fraction, that might be hard to find on the graph. So that's just kind of the downsides. We had really clean numbers when you guys were doing your intercepts on these problems. So that's why these worked out nicely. All right, guys. Well, that one's that pretty easy one. I will see you later. Bye.